Welcome back. In the last video, we talked about models, what a model is in our data analysis course, and now we want to talk about functions. So a model, normally when we talk about a mathematical model of something, it will be a model that is constructed out of functions as its building blocks. And a function in mathematics is a kind of relationship between some input and some output. So let's get an example. For a function, I can increase a number by 1, right? Then I have a mathematical function. So the input would be 2, and then the output of this function is the number 3. Or the input can be 512, and the output will be 513. So this function is a function that adds 1 to whatever I give it. I can have another function that has an input or an output that is not mathematical, that does not use numbers. Functions can be defined over objects and interact with objects. I can have a knife. A knife represents a function that can cut a thing in half, let's say. So I have a few cakes and I have my knife, and I bring a piece of cake and my knife cuts this cake in half and produces 2 half-sized pieces of cake. So this is also a function. I have an input, I have an output. I can have a function that glues things together. I can have a function that takes the parts of a bottle, let's say, right? It takes the bottle and it takes the cap, and then I screw them together. And my output is a bottle with a cap. This happens in factories, right? When they produce beer bottles, they produce the bottle of the beer, they produce the cap, and then they fill the beer in with a machine and they put the cap on it. And this is a machine that does that. And this machine, you can say, performs this function. It takes the bottle, it takes the beer, it fills it in, and then it takes the cap and puts it on top and seals it in some way. And this is the function that this machine performs. So all of these are relationships between input and output. You have some input, you have some output. Your car is the same. It has an input of fuel, petrol or electricity, and it has an output, and the output of the car is its change of location, right? Its speed, its acceleration. These are outputs of the car. And there's a special vocabulary when we talk about functions. There are these words domain and range. The domain is the set of inputs that the function can take and process. And the range is the set of outputs, of corresponding outputs that the function will produce given that domain of inputs. So when I have a function that increases a number by 1, the domain is the set of possible inputs, all numbers that can be increased by 1, and the range is the set of all possible outputs, all other numbers that are the input number plus 1. When I have a function, a relationship that cuts a cake into 2 pieces, the domain are pieces of cake, and the range are also pieces of cake of half the size. My car implements a function. The domain is the set of all fuels that the car can process, and the range is the set of all locations that my car can reach. Or accelerations, right? Or speeds. It depends on what we are looking at in the car, which output value is interesting. Things like cars have, of course, they have multiple output values. They don't do only one thing. They use up the fuel, they produce exhaust. I could say a car is a function that produces exhaust gas. Then I would measure the amount of exhaust gas. Or I can say a car is a thing that accelerates. Then I would measure the acceleration as the output of the function. Or I can measure the speed, or I can measure the location, the change in location. So whatever I measure depends on what I measure, and then I will have different outputs to my function. Take books and authors as another example. Finding a book's author is a function, the book's title is the domain, the input, and the domain is the set of all book titles whose authors I can find, and the range are the authors who have written books that I know of. Counting the words in a sentence is a function, the input is a sentence, the output is a number of words in this sentence. The domain is all possible sentences, the output is all possible numbers that correspond to words in a sentence. So now these are relationships between input and output. A function in mathematics is a little more specific still, because there is one additional requirement that it has. For each input, there must be exactly one output. If a function does not do that, then it's not a function, it's just a relation. And there can be different relations that produce different kinds of values, but if it has to be a function in the mathematical sense, it has to have one specific output for every input and not multiple. So to visualize this, if you have a book and you want to find its author, then this is a function, assuming we have only books with one author now, right? Then you give it the title and let's say the Odyssey, and the result is Homer. And so you have the book maps, this input to one output, to the author. You have From Whom the Bell Tolls, the output is Hemingway. The opposite thing, you have the author name and you want to find what books they have written. This is not a function in the mathematical sense, because for every author there can potentially be multiple books. Homer wrote the Iliad and the Odyssey, so it maps one name, Homer, to multiple books. Then it's not a function. Or Hemingway wrote multiple books, For Whom the Bell Tolls and The Movable Feast, and lots of other books. And so again, if I try to map it in this way, it's not a function, because every input, in this case Hemingway, has multiple outputs, the books that he has written. So this is the limitation with functions. They have to have only one output. This is not a problem for us here so much, because in this data analysis course we are not interested in pure mathematics. We're interested in applying the thing and applying it through Python in a programming language, in a programming environment. And actually in Python, this distinction doesn't make much sense, because Python functions can return complex data structures. You can have a Python function that returns one list, and one list can contain as many elements as it likes. And so I could take the author name Hemingway and return a list containing his books, and this then would still be a function in Python and in mathematics, because I return only one thing. I return one list. And so in this way, I can cheat my way around this definition. And this is why in Python everything is a function. There are no other non-functional relations, because I can make any relation into a function just by returning a complex data type that then will be one thing containing multiple items. Okay, so just don't bother too much about it. It's just a definition we need to know when we talk about functions. Mathematicians expect it to have one return value for every input value. And okay, so this is it with functions. Let's stop here. I will make these units very small so that you can easily listen to them without having to commit half an hour to the thing. Next thing, we will talk about how to visualize functions in Python. So make sure you come back to that. Just take the next video that appears here, and we will meet again in a moment. Thank you and goodbye.